Hello, math is myth. All right, guys. So welcome to competitive programming with CodeChef. So if you guys can hear me, see me, and see my screen, kindly drop a thumbs up in the chat section so that I know that everything is all right on the technical aspect. Is everything all right in this YouTube place? So, guys, if you can just drop a thumbs up or say something so that I know that you can see my screen properly, you can hear me. Thanks. Okay, so let's proceed. Okay, so welcome to the second session on our hashing. For those of you who don't know me, I am Rohit Mazumder. I am a final year student from Jadavpur University. I was a former intern at Amazon, and recently we started a micro course here on this platform. This micro course is on hashing. The previous class was a very theoretical introduction to this subject matter. We understood what hashing is all about. We understood how hashing takes place, what are the various parameters for hashing. So we understood, we had gained a very in-depth understanding about the theory of hashing. In this session and in the upcoming session, we are going to solve some problems in hashing. This session is solely towards the beginner level problems. So we are going to be looking at the very basic questions in hashing, and we are going to slowly increase the difficulty step by step so that we can get accustomed and master this topic. All right. So without much further ado, let's move on. Okay, so let's pick up where we left last class. So in the last class, as we discussed, that hashing is being implemented using we discussed about the various library classes which implements hashing. For example, in Java it's hash map, and for in C++ it's an unordered map. So basically, in this class, I will be using Java for coding. So are you guys familiar with Java? How much are you comfortable in Java, or are you guys more comfortable in C++? So for users who will be coding in C++, so I wanted to say that who are the people who are not much comfortable in Java, it's don't worry about it too much because the implementation is going to be very simple to follow. So basically over here I have posted a comparison between the two. On the left hand side you can see the API functions for Java, and on the right hand side you can find the corresponding implementation in C++. So in case if you are a C++ users, just have a look at this. It's not going to be very difficult to follow. It's the matter at hand is going to be very same, and we are going to be discussing about the core logic before we proceed. All right, so for Java, we have the function, we have the library class which is known as the hash map. The hash map takes in the two parameters, integer comma integer. The first integer refers to the data type of the key, and the second integer refers to the data type of the value. For C++, we have the unordered map. The unordered map has is in the same way takes in the two parameters, the int comma int. The first int refers to the data type of the key, and the second integer over here refers to the data type of my value. Similarly, for adding a new key value pair, we have to use the map.put function in Java. So the put function will insert a new relation from key to value in Java, and for in C++ you can just simply use the same type of syntax as that of an array. You can just put your map and you can just put the key inside a third braces, and you can just put the value in there. To look up for a particular value, you can just use contains key method in Java, and for C++ users you have to use the find method, and if the find method returns map.end, then that means there is no key present in this map. Otherwise it's going to return you a otherwise it's going to not return you a map.end. To retrieve a key value pair in Java, we need the get function. So if we call map.getKey, we are going to get the value corresponding to this key. And for C++, it's just simply calling the it's simply it's simple as that of an array. You just have to pass in the key and you'll get the value. In Java, we have an extra method out here which is known as the get or default method. Its method is very easy to follow. So what this method does is that it takes in some key and it will return you the value corresponding to this key. In case this key is not present in this map, it's going to return you this default value. For C++ users, there is no such equivalent to this function, but it's very easy to code this function out in C++, so it's not a big deal. So just to recap, so map.get or default, what it does is that it takes some key and it is going to return you a value corresponding to the key, and in case the value is not present, then we are going to return this default value. So anyways, let's without wasting much time, let's just jump to the first question at hand. Okay, so the first question is going to be a very basic question, guys. So this question is it's very simple and very basic, and this most of you might have seen this question before. So this is a question which is very important also if from your interview perspective. This is one of the questions which is asked frequently in interviews. So you have been provided with an array which is 0 indexed and it's of length n, and you have been provided with a number which is a target. You have to find the number of pairs ai, aj, where I is less than j, in the array whose sum is target. So that is to say that you have been provided, the first line contains an n and a target. The first line contains n, which is the size of the array, and the target number, which is a 6, and the next line contains the contents of the array. The next line contains the contents. So these are the contents of the array. So provided this contents of the array, now we need to find out the number of pairs such that the sum is the target. For example, if you take this example at hand, the example at hand is 1, 7, 5, -1 and 1. So this is the array provided to us in input. Now we need to, and we have been provided with a target. We have been provided with a target which is a 6. So we need to find a pair of elements from this array which adds up to be a 6. So for example, you can take this 1 and you can add a 5 to it. So if you take this 1 and 5, then this pair is going to add up to be 6. This pair is going to add up to give you a 6. Or even you can take this 7 and you can take this -1. So this is also going to return you a 6. Similarly, you can take this 5 and you can take this 1, and this is going to return you another 6. So these are the 3 possible pairs from this array. Now note, guys, one thing to note is that this pair is not valid. This pair is not valid, although -1, 7 is also going to give you a 6, -1, 7. But this pair is not valid because we have been set explicitly in this question that we have to pick I and j such that I is less than j. So 7, -1 is valid, but -1, 7 is invalid. So the number of pairs in this array is 3. So just take a minute to think about this question, guys, and if you have any problem or any doubt in understanding the problem statement, just let me know. So is everyone clear with the problem statement? Just drop a thumbs up if you have understood the problem statement clearly. Great. So now let's proceed. Okay, so let's proceed with the solution. Before jumping into the actual solution, I want to take a minute and just think about the most simple approach we can think of here. Alright, that is the brute force approach to this question. So how do we solve this using a brute force? What is the most simple thing which we can think of here? The most simple thing you can think of here is to generate all pairs. If we can generate all pairs. How do we generate all pairs? Let's say that what do I mean by generate all pairs? So let's just copy the array out here. So the array provided to us is 175 -1, another 1. So this is the array provided to us. So what if we can generate all the pairs 1, 7, 1, 5, 1 comma minus 1, 1 comma 1, 7 comma 5, and so on. What if we generate all the pairs and then we find out the sum of them? 1 plus 5 is 6, 1 minus 1 is a 0, and then we select how many of these pairs have same number, has the same sum as that of the target, and we can increase our sums sort of a count. So this is the most basic thing which we can do. We can generate all pairs. We generate all pairs. After we generated all the pairs, we find out the sum of numbers we find the sum of the numbers from each pair, and then if that number is equal to the target, we increase the count. So this is the most simple thing. Now, how can we generate all pairs? How can we do this? So how can we generate all pairs? So generating pair means two elements. So basically, if you have to generate all pairs, you have to just select two elements from this array. So you have an array and you have to select two elements. How do we select two elements? We can select two elements using just two loops, or more precisely using a nested loop. Okay. So this is basically a brute force, some sort of code, a snippet which I had written previously. So it takes in the array, it takes in the size of the array and the target. So these are all the parameters which has been provided to us in the input. So what it does is that it takes it has a nested loop. So the first loop, which is a j loop, what this does is that what this loop is doing is it is selecting the a of j, and inside this loop we have another loop which is selecting the a of I. So now this loop runs from 1 to n, and the inner loop runs from 0 to less than j. So this condition is enforcing the condition given in the question. So if you look at the question, we had been enforced the condition that I always needs to be less than j, that is this pair is not possible. So this condition is being enforced over here in the loop. So we are running a loop which is selecting a of j such that j is between 1 and n, and we are running another loop which is selecting the a of I, and this I loop is running from 0 to less than j. And after that, so when we are inside this nested loop, when we are in here, then we have access to we actually have generated a pair a of I comma a of j. So once we have generated a pair, we just find the sum of the elements of the pair and see if it's equal to the target. Then we increase our count, and otherwise we don't do anything, and at the end of this nested loop we just return our result. So this is the most basic thing which we can do. Is everyone clear on this brute force? Just drop a thumbs up if you have understood so far. Okay, so guys, so now since we have all understood the brute force approach, so can you guys tell me what is the complexity, what is the time complexity of this solution? Yes, Manjur, the time complexity is an O of n square, correct? Big O of n square. So this is the time complexity which we have achieved over here. Now let's try to improve upon this solution. Let's try to improve upon this solution. To improve upon the solution, I am going to analyze this solution a bit more. So in this solution, we have been said that to find the number of pairs. So the question was that find the number of pairs ai comma aj such that ai plus aj equals to some target. Let's say that let's fix a of j. Let's fix a of j. Let's bring back the array from the question. So the array provided to us is 1, 7, 5, minus 1 and a 1. So this is the array provided to us. Now let's fix a of j to be some number. Let's say that a of j is this number 5 out here. So let's say that a of j is this number 5 out here. So let's solve a different question now, guys. Instead of finding the number of pairs ai comma aj such that ai plus aj is equal to target, I want to find the number of pairs ai comma 5 such that ai plus 5 equals to the target, and the target provided to me in the question is 6. So or we can say that we want to find the ai, the number of ais such that it's target minus 5, which is 6 minus 5, which is a 1. So we want to find the number of AI, that is the number of ones in this array before this 5. Why before? Because we want to enforce that condition I must be less than j. So if we fix a of j to be 5, I want to find the number of ones in this array before this 5. So before this 5 in this region. So if you observe closely, it's exactly what we are doing. In this step, we are fixing some a of j, and then in this inner loop, what we are doing is that we are figuring out a of I, which is equal to target minus a of j. So if you shift this a of j to the right hand side, so it's a of I equals to target minus a of j. So basically what we are doing is that we are fixing a of j. So the outer loop is fixing the a of j. So it's fixing a of j, and this is finding a of I. So the outer loop is fixing the a of j, and the inner loop is finding the a of I corresponding to this a of j, where a of I is equal to target minus a of j. So that's all it's doing. So wouldn't it be great if we can just eliminate this second loop completely and find out this answer? So it would be great, right? So so basically this loop is the time consuming part. So it's O of n squared just because of this loop. If we can just get rid of this loop somehow and find out how many AI are there before this particular point, the frequency of this AI, then it would be great. And as it turns out, it's very simple, guys. So this is perhaps one of the most simple application of hash map, which is finding the frequency of each and every element in an array. All right. So what do I mean by frequency of each and every element in an array? Suppose that you have an array provided to you, which is 1, 3, 1. All right. So we want to find the frequency of each and every element of this array. Let's say that we want, so the answer would be the one. So the answer would be something like this. That is, we have the number 1 occurs 2 times in this array, and the number 3 occurs only once in this array, right? So we want to find the frequency of each and every number in this array. So if I have an array 1, 3, 1, my answer should be that the number 1 occurs twice in this array and the number 3 occurs only once in this array. So this is basically a very simple application of hash map or an unordered map if you are a CPP user. So this is perhaps the most frequently used application. So here is a code snippet about how you can do this. So this is a very simple code, but let's see what's done over here. So we have declared some hash map, and this hash map is creating a mapping from element to frequency. So we will be storing a mapping from each element of the array to their corresponding frequencies. So something like this, each element of the array corresponding to frequencies, which we want to store a mapping like this. So now we declare the hash map integer comma integer, and this line, what this line is doing is that it's picking some element for in this loop. So we are going through a loop and we are picking each and every element from this array. We are picking each and every element from this array, and we are figuring out the number of times this number a of I has already occurred in this array. So that is my previous frequency. Then I'm just increasing the frequency by 1 and I'm just putting it back in my map. So in case if you are a CPP users, by the way, for CPP users, this thing would be reduced to something like this. So what we are doing is that we are taking each and every element from the array and we are just finding out the frequency from this map. So we are asking this map either give me the frequency, which number of times which this a of I has already occurred in the array. If this element hasn't occurred yet, then just give me a default value of 0. So it's get or default, either get me or give me the default value. And once we find that previous frequency, we increase this previous frequency by 1 and we put the mapping back into our map. Has everyone been able to follow this code? Just give me a quick thumbs up or let me know if you haven't been able to follow. Yes, Manjur. So let's say that you have an array like this. Let's say that I have an array like this. And my target, okay, let's use some brighter colors. Right. Let's say that I have some array like this. All right, and my target is to find the frequency of each and every element in this array, that is the number 1 occurs twice and the number 3 occurs once. Now let's try and do a dry run of this code. What the first step does is that it's declaring a map. So it's declaring some map. Before this loop, this map is empty. That is what I am representing by this curly braces, that this map is empty. So now I'm going to come inside this loop and I'm going to call this function get or default a of I. A of I is initially this element, which is 1, 0. So now I am searching for this 1 in my map. I am searching for this 1 in my map. Since this map is empty, there is no 1 in this map, it's going to return me the default value 0. So now my previous frequency returned will be equal to 0. Now I'm going to add a 1 to this previous frequency. Now I'm going to add a 1 to this previous frequency and put it back in my map. So now my map basically becomes something like this: 1, 2, 0 plus 1 is 1. Now let's take the next element. The next element is a 3. We are going to do the same thing, get or default 3, 0. Now this is get or default 3, 0. Now once again, if you check this map, there is no 3 present in this map. So this pref frequency will contain this value 0. So this function is going to return this value zeros, which will be stored in this pref frequency. So we are going to add 1 to this pref frequency and put 3, 1. So now this map becomes something like this. Now this map becomes something like this: 1 to 1 and 3 to 1. Then I'm going to come to this element. This is a 1. So I'm going to ask again get or default 1, 0. Now this time there is a 1 present. So the pref frequency returned is not going to be 0, but is going to be this value out here, which is 1. So we are going to add a 1 to this and put the mapping back. So now my map will contain 1, 2 and 3, 1, which is exactly what we needed. We needed this frequency mapping. We got it here. Is that clear, Manjur? Okay. So everyone is on the same page with this code. Okay, chalo, let's proceed. Okay, so this is how we can calculate the frequency of each and every number in an array. So now using this logic, let's try and approach this question once again. Chalo. Okay, so just a second. Let me share my screen. Can everyone see my screen? Okay. What about you YouTube users? No one on YouTube. Chalo. Okay, so I have pre-written some boilerplate code about taking all the inputs and stuff. So let's just skip that part and let's just jump right to writing this function. All right, let's just jump right to writing this function. So I want to write this code where I have been provided with an input array. So let's take a look at the input array. We have been provided with some input array, and we have been provided with a variable n, and we have been provided with a variable target. All right, and we have to find the number of pairs such that a of I plus a of j is equal to that target. All right. So now let's declare some element. So this count, okay, so this count is 0. This variable will contain my answer. This variable is going to contain my answer. Now let's declare my hash map, which is going to be map is equal to new hash map. So this hash map is going to contain my mapping from elements to frequency. Once I'm done with that, I want to run a loop. Int j equals 0, j equals less than n, j plus plus. So what this loop is doing, it's fixing some value for a of j. So we have to calculate a of I, which is target minus a of j. Now let's find the frequency of a of I equals map.get or default a of I comma 0. Count plus equals to frequency. So this, what this line is doing is number of occurrences of the value of a of I before index j is equal to frequency of a of I. Map dot put j map dot get or default 0 plus 1 here. So we return the count. Right, let's try this out. So the input provided to us is 5 minus 1 1, which is a 3. All right, so what we are doing out here is that we are taking in the hash map. So we have declared a hash map out here which contains the mapping from my elements to my frequencies. Then I am fixing a of j. This is something which we have done earlier. We fixed a of j, and corresponding to that a of j, my a of I should be target minus a of j, right? So if I fix my a of j to be 5, then it should be my so my a of I should be 6 minus 5, which should be 1. So a of I should be 1 in this example. So then I am finding my a of I for this fixed a of j. Then I am finding the frequency of, that is the number of times this a of I has occurred before this index j, using this, simply using this. We just learned about this, and then we are just adding the frequency. So we are doing this so we are fixing a of I, the value of a of j for each element on in accordance to each element of the array, and we are finding the corresponding a of I, and we are keeping on doing that. And at the end of this function, we are just returning the count. Just take a minute to take a look at this code, guys, and then just let me know if you have been able to follow. Yes, the complexity reduces to O of n, correct, Aisha? So have you been able to follow the code, guys? Just send me a thumbs up. All right, let's proceed then. Okay. Okay, so here are some similar questions to these questions. Can you guys see my screen now? The slides. Can you guys see the slides? All right. So now the question is that we have been given. So now we will solve some very similar question to this one. The question is that you have been provided with some numbers in the array. Now you have to find a pair of numbers such that the sum of the number is the target. So this is pretty similar to the previous question. In the previous question, we had to find the number of pairs, but in this case, we just have to output one of the pairs. Like for example, in this input, if you have been provided with this question, if you have been provided this, if you had been provided with this input, you can output any of these pairs. You can output this or this or this, any of these pairs. So this is this question is left as an exercise for you guys. So now let's, and the next question is that you have been given an array and you have to find the number of pairs with a given product. So both of this question is very similar to the one we did right now, so I'm not going to go into this question. I'm leaving these questions as an exercise to you guys. Try it out and have fun. Okay, so now let's move on to the next question, guys. So now this question is a generalization on the question on the previous question, guys. This question is a generalization on the previous question. So in the previous question, we were provided with a target, and we were provided with a basically an array, and we were asked to find the number of pairs in this array such that the sum of the elements in the pair was equal to the target. In this question, instead of pair, you have to find the number of sub arrays. So you have to find the number of sub arrays whose sum is equal to the given target. So this is a much more generalized version of the previous question. So what we have to do is that, let's say that we have been provided with this input 5, 4, 3, 2, 1. So we have been provided with this input, and now what we need to do is we have to find out the number of sub arrays whose target sum is 3. So we have several sub arrays like this, we have sub array like this, there are many sub arrays. So we have to find out the sub arrays whose sum is 3. So none of these actually. So what are the possible sub arrays whose sum would be 3? One sub array would be the element 3 itself. So the element 3 itself is a sub array which has a sum 3. Another sub array can be 2, 1. So in this case, it's 2 plus 1 equals 3. So these are the two sub arrays whose sum is going to be 3. Based on this, we have the answer 2. So now guys, take a minute to think about this question. I'll give you guys a few minutes to think about this question, and then we will proceed further. Alright guys, any leads on this question? Any idea how we can solve it? Yes, Arunava, that's a correct lead. This can be solved by finding the cumulative sums. Alright guys, so before we proceed with this question, I wanted to take a small detour. I want to take a small detour and talk about something called prefix sum. Yeah, So yeah, correct answer. So we need to create a prefix sum array. So let's see what is prefix sum all about. So to understand prefix sum, we are going to take up this motivation problem. So this motivation problem says that we have an array of zero indexed array of n integers, and we have to perform q queries on this array. Each query will be provided with two integers L and R, and this for each query you need to find the sum of elements from L to R. That is to say that, let's say that suppose you have been provided with some array. Let's take some array. Let's say that the array is 1, 3, minus 1, 2, 1, 2, 1. Yeah, so it's 1, minus 1, 2, 1, minus 3, 4, and 5. Let's take this array. For this array, so we need to find, let's say that we need to find the query. Let's say the query is 1 and R is a 4. So basically it's 0, 1. So 1 to R is a 4. So 4. So basically it asks us to find the sum of this region. That is, the answer should be equal to 3 minus 1 plus 2 plus 1, which is a 5. So your answer should be 5. So this is one of the motivation problem behind the prefix sum queries. So what we have to do here is that the most simple thing which you can do is that for each query you can just run a loop from L to R, and then you can find the subarray sum. So that is something you can do. So that is going to take a big O complexity of big O of q of n, q into n, where q is the number of query. And for each query you have to run a loop from L to R, and you have to add all of these elements, and you have to output the answer. So that is something which you can do. So that is, but now if you take a look at the constraints, the constraints are that the size of the array is around 10 to the power 3. Each element of the array is between a negative 10 to the power 5 to 10 to the power 5, and the number of queries is actually quite large, which is 10 to the power 9. So in case you're using this approach, it's not going to be good time wise. So it's going to consume a lot of time. So instead we have a different approach which is known as a prefix sum approach. So I'm not going to be talking into much details about this, going into much detail about this thing, what is prefix sum. Maybe we can have a separate session where we can discuss this concept in much more detail, and maybe we can solve some more questions about this. But for now, let's take a small step into knowing what prefix sum is all about. So the prefix sum tells us that if we have a prefix sum array, tells us to first calculate this prefix sum array. So prefix sum is nothing but the sum of all elements from the index for sum of all elements in the array A from before and including index I. That is to say that if you have this array, let's write the array over here again. Let's say that I have this array 1, 3, minus 1. 2, 1, minus 3, 4, and 5. Let's say that I have this array, and from this array A I want to calculate my prefix sum array. So what does prefix sum mean? Prefix sum means I have to calculate sum of all elements in this array A before and including index I. So for the first index, it's going to be the sum of all elements in this region, that is 1. For the second index out here, it's going to be the sum of all elements in this region. So it's 3 plus 1, 4. The next is going to be the sum of all integers in this region. So 1 plus 3 minus 1, which is a 3. The next one is going to be in this entire region. So it's 5. The next one is going to be 6. The next one is going to be 3. The next one is going to be 7. And the final one is going to be 12. So this is a prefix sum array. Now it tells us that, the second step tells us that if we have a prefix sum array, if we can create a prefix sum array, then to calculate the subarray sum, we can use the formula prefix sum right minus prefix sum left minus 1. This is a very important concept of competitive coding, guys. This is a very, very important concept in competitive coding. So this is the formula for subarray sum. So let's take a look at why this is working. Consider this as my array. So this is my array A, and this is my prefix sum array. This is my prefix sum array. Alright. So for each index, let's suppose this index 6, suppose this element 6, which is colored green out here. This 6 is actually representing the sum of all elements in this green box. It's representing the sum of all elements in this green box. Similarly, this element 1 is representing the sum of all elements in the red box. Now we have been asked to find a query, that is the query is that we have to find the sum of all elements in the sub array from L equals 1 to R equals 4. So we have to find the sum of all elements in this range. So to do that, what we need to do is that we need to take the sum of all elements in this yellow green box, and we need to remove all the elements which are coming before this L. So since we are removing all the elements before this L, so we have to basically take this green portion and we have to basically subtract the red portion out of it. So the green portion is given by prefix sum R, and the red portion is given by the portion before this L. So it's prefix sum L minus 1. So that's the proof, guys. That's the very intuitive proof about this. So if you calculate for this query, it's going to be 6 minus 1 equals 5. Now if you calculate the sum of elements from L to R, you will find that the answer is 5. So the answer is 5. 3 minus 1 plus 2 plus 1 is a 5. So that's about prefix sum, guys. Now very interestingly, quite interestingly, this prefix sum, the first step, that is calculation of a prefix sum, can be very easily done using dynamic programming in an O of 1 query. That is to say that, let's say that you have something, let's say that you want to calculate the prefix sum, let's say that you want to calculate the prefix sum 3. The prefix sum 3 is nothing but A3 plus A2 plus A1. Right? Now this portion can be rewritten as A3 plus prefix sum 2. So similarly, for any index I, you can have prefix sum, prefix sum I equals prefix sum I minus 1 plus A of I, and the first index of a prefix sum element is always the that index itself. So the first index is always the same. So the base case is that prefix sum of 0 is going to be A of 0, and the prefix sum of I is going to be prefix sum I minus 1 plus A of I. Is this clear to everyone? Just drop a thumbs up. All right. That being said, let's get back to our original question at hand. So this is the sorry, this is not the question at hand. Yeah, so this is the one. Yes. So now that we have an idea about sub arrays, now that we know what sub arrays are, sub array sum, how can we calculate sub array sum efficiently, let's go and try and solve this question. So this question basically asks us to find the number of sub arrays. So basically it's asks us to find the number of sub arrays with sum equal to target. So that's the question. Now we know that sub array sum can be replaced by prefix sum R minus prefix sum L minus 1. So this so we have to find the number of sum sub array with sum equals target is number of prefix sum minus L minus 1 equals target. So this can be written in form of this using the formula we just learned. Now, or we can say it something like this, that we need to find the number of pairs, R comma L such that prefix sum R minus prefix sum L minus 1 is equal to target. Is this clear to everyone? Is till this step? Good. So that being said, so this question basically now reduces to the first question, basically reduces to kind of same as the first question we solved. In the first question we were asked to find the number of pairs such that the sum was equal to a target, And in this question, we have basically reduced it to a similar type of question in which we have to find the number of pairs where the difference is equal to some other target. So this can be very easily solved. Now let's get back to the coding. So this is the question. We have the inputs and everything ready. So let's code it out. So we will create some result variable. So this contains a result. This contains result. Next step we're going to do is that we're going to declare a hash map. Teacher, teacher map is equal to new. Next step is, so this is going to clean mapping from So guys, we don't need to explicitly calculate the prefix sum array. We can do it using a running sum. As you can see, we can just create a running sum. Okay, so we can run a loop and we can keep adding elements to this variable. So at any point of time, if someone asks you what's the value of current sum, it's equal to basically prefix sum r, right? Because when you are at index r, when you are at index r, you have already added all the elements which are coming before r and including this. So at any point of time, when you are taking the value of current sum, it's basically prefix sum r. So we don't need to create the array explicitly. We can just keep adding to this. So now, so since we have, now we know that prefix sum r minus prefix sum l minus 1 should be equal to my target, or we can say that prefix sum l minus 1 or we can say that prefix sum l minus 1 is going to be my prefix sum r minus target. So, and since we said that prefix sum l minus 1 equals to, since prefix sum r is same as the current sum, so we can replace prefix sum by current sum. So current sum equals to, current sum is going to be current sum minus target. So that's it. So now let's write the code. So this is the commented portion. Let's write the code based on this. So what I'm going to do is int frequency is going to map dot get or default current sum minus target, and it's going to be a 0. We are going to add this to our result, and we are going to put increase this by 1. Okay, let's try and run this code now. Okay, so the input provided to us is 5 3 5 4 3 2 1. Yeah, so the answer is 2. So what we are doing, guys, is that we are declaring a variable. This variable contains the result, obviously. So we are declaring a hash map which is going to contain the mapping from prefix sum to the frequency. So this logic is basically very similar to the previous logic. So this is the previous code. So now what we are doing is that we are fixing an R. So we are fixing some so basically this step is basically fixing the prefix sum R. So at any point in time, current sum is going to contain my prefix sum R, and this prefix sum R, so current sum is actually prefix sum R, and we know that prefix sum R minus prefix sum L minus 1 is going to be my target. So from this equation we can calculate that prefix sum L minus 1 is going to be prefix sum R minus target, and we can replace this prefix sum with this current sum variable. So current sum minus target. So since we have kept the prefix sum R fixed, we have to find the frequency of previous occurrence of prefix L minus 1. So this step is very similar to this step out here. So this step is very similar to this step out here. We have to find in this case we had to find out the number of AI before index j. So very similarly, we are over here we are finding out the previous occurrences of prefix L minus 1 using this current minus, which previous L minus 1 is current sum minus target. So we are finding out the number of previous occurrences. We are adding them to our results, and then we are increasing the frequency of the current sum by 1, and we are finally returning the result. Okay, so has everyone been able to follow this code? Just put a thumbs up or thumbs down. I'll just give it a minute to go through the code again. So just check it out if you have any problem. Alright, guys, so proceeding forward, so this code is actually not a foolproof code, guys. This code is actually not a foolproof code, and I can prove it to you using a very simple example. Let's take another example. Okay, so let's say that I have some sort of an input like this. Okay, so the input which I am providing is 0 0 0 0 0. All right, and the output is 10, but this output is wrong. This output should be 15, guys. So let's see, why should it be 15? So let's say that I am taking some output for n equals 5. I am taking some output 0 0 0 0 0. So this is some input I have been provided with this input. Now I need to find the target. Let's say that my target sum is a 0. In this case, the number of sub arrays, if you take any sub array, that the sum is going to be 0, because all the elements of this array is 0. So if you take any sub array from this array A, it's always going to end up with the sum 0. That being said, so the number of sub arrays, we know that the number of sub arrays in an array is always n times n plus 1 by 2. I'm not going to go into the proof, guys. It's very simple. So n is 5 and n plus 1 is 6 by 2, which is 15. So the output here should have been 15, but our output is 10. Why is it so? Let's take a look at this code once again. So the reason why we are missing out on sub array is that our code is failing to calculate all those sub arrays which are starting from index 0 and ending at some. So it's neglecting. It's basically neglecting all sub arrays which are starting at index 0 and having sum equals target. So why is it neglecting, guys? So the reason why it's neglecting is that if you have a subarray which is starting at index 0, and let's say that we have some subarray which is starting at some index 0 and is ending at some index r. So in this case, this subarray sum, if you take a sum of this subarray, of all the elements of this subarray, then it's going to be represented by prefix. It's going to be represented by prefix sum r minus prefix sum l minus 1, which is actually a minus 1. Since l is 0, it's going to be a minus 1. So this is the reason why this technique is not a foolproof technique. This prefix sum technique has this one fault, is that when we have the l at 0, prefix sum l minus 1 gives us a minus 1. Since this is a minus 1, we cannot find the sum of the subarray. So the only way to do so is to explicitly add those subarrays ourselves. So to do that, what we do is that if current sum is equal to target, so current sum is prefix sum of r, right? So if current sum is equal to target, so current sum presently has all the sum of all the elements from index 0 up to r. So if current sum is target, same as target, so we increase the count over here. So this is what we do explicitly out here. Now let's check this. Let's check with this input again. Bingo. Now we have a foolproof solution to this. So guys, have you been able to follow so far? Just let me know. If you have any question, feel free to ask. So guys, can you tell me what is the time complexity of this code? So here is the code. So can you guys tell me what is the time complexity of this code? Yes, Aisha, the time complexity is O of n. So we have a single loop out here. So all we have is a single loop, and in this loop we are just calculating the sum, and we are doing all modification, and every so every call to the map, every call to the hash map, like get or default or put, is an O of 1 operation. In case you are not aware of this, that how is it an O of 1 operation, make sure to watch our previous video where we have covered this in much details. All right, so let's move on to the next question. All right, so let's move on to the next question. Okay, so now we have a pretty similar question out here. In this question, now we have been given that you are given an array A where each element is one of the two characters R or B, representing the color red or blue respectively. You have to count the number of sub-arrays where the number of reds and the number of blues is same. So you have been given some sub-array, maybe you have been given with some sub-array like this, R, B, or something like this. You have to calculate the number of sub-arrays where the number of red and the number of blue is same. So you can, if you create all the sub-arrays, it's going to be RB, RBB, RBBR, something like this. There are going to be many arrays. So this is one valid sub-array, this is one valid sub-array, another valid sub-array is going to be B, R. So these are all valid sub-arrays. Yeah, so basically you have to calculate the number of sub-arrays where the counts of where the number of reds and the number of blues occur in the same numbers. So this question, guys, is a very similar question to the previous question which we just covered. This question can be actually reduced to the previous question. Just take a minute to think and let me know if you can figure it out. How can we reduce this question to the previous question? Just take a minute to think. Yeah, correct. Correct, Arunava and Atre. So basically, what we can do is that we can take the array and we can transform it. So what we can do is we can transform it. We can transform each r to a 1 and we can transform each b to a -1. So if we transform this array, now the question reduces to finding the number of sub arrays such that we have equal numbers of ones and -1s. That is same as saying that we have to find the number of sub arrays which has the sum 0. So we have to find the number of sub arrays with equal numbers of ones and -1s, or the number of sub arrays. If you have equal numbers of ones and -1s, then the sum is always going to be 0. So the number of sub arrays with sum equal to 0. So now this question basically reduces to the previous question in this question. So basically now you have a array and you have now in this question. So basically now you have an array and instead of this target you have to find all arrays which has a target of 0. That is the sum is 0. So this question can be pretty easily solved using the previous logic. Okay, so we have another question of the same kind. In this question we have been said that given an array where each element is one of the three characters, and the three characters are R, B and Y, representing the colors red, blue and yellow respectively. You have to count the number of sub arrays where the number of reds, the number of blues and the number of yellow are the same. So this question is pretty similar to the last question. I'm not going to be solving this question with you guys. This is also left as an exercise for you guys to try at home and have fun. Okay, so now moving on to the new type of question. So this is also pretty similar. Now this question says that you have been given an array A where each element is one of the two characters R or B, again representing the colors red or blue respectively. Now you have to output the maximum length of sub array which has the equal number of R and B. So for example, if this is the example given to us that you have an array R, B, B, R, B, R, R. So you have been given this and the output, if you consider this sub array, you can see that R, B, B, R, B, R. So you have 3 R's and 3 B's. So basically this is the longest sub array. So basically you have to output the maximum length of sub array such that the number of R and number of B are the same. So again guys, take a minute to think about the solution and let me know if you have any leads. Yes, Aisha, we can first replace all the R's and B's with ones and -1. Okay, so that is one thing. What's next? Next what? What do we do next? Alright, so if we replace ones, 1. Then prefix sum. All right, okay, Alright guys, let's start with the solution. Okay, so let's say that we have been provided with this array A, which, as Aisha said, we can convert it into an array of ones and minus ones. So if we convert it into an ones and minus one, it's going to be something like this: 1 minus 1 1 comma 1. So this is something like this. Right now, let's say that we have been asked to find the not the number, we have been asked to find the maximum sub array length with sub array sum equals 0. So this is the question. If we make the transformation to ones and minus ones, then this is the question. So the question changes into finding the number of the maximum subarray length whose subarray sum is going to be 0, because the subarray is going to have equal numbers of ones and minus ones. So if you have a sum of all the elements in the subarray, it's going to be 0. So the question reduces to finding the maximum subarray length with subarray sum equals 0. So now we know that we can always convert max subarray sum to using the formula we just learned in the previous section, that we can replace with prefix sum r minus prefix sum l minus 1. So we can replace subarray sum with this formula. We just learned about this formula a little while back. Or we can say that we can just bring this prefix sum l minus 1 to the right hand side of this 0 and make this prefix sum equal. So we can say that the maximum subarray length with prefix sum right equals the prefix sum l minus 1. Also guys, if you consider any array, let's say that we are considering some array with some indices. Let's say that this index is my r, and let's say that this index is my l minus 1. When we are considering a sub array sum with r and l minus 1, we are basically considering this sub array from l to r, and the length of that sub array is nothing but r minus l plus 1. The length of this portion of this sub array is r minus l plus 1. Is that good? Are you guys able to follow? Good. Yeah. So what's going on is that so we have replaced this sub array sum with the formula that prefix sum r minus prefix sum l minus 1, and we have pushed this prefix sum l minus 1 to the right hand side. So we have the maximum sub array length with prefix sum r equals prefix sum l minus 1. Or we can say that we have to find the maximum value of r minus l plus 1 with prefix sum r equals prefix sum l minus 1. What this means is that if we have this array, let's take this array A. Okay, let's take this array A. Which is 1 minus 1 1 minus 1 minus 1 1 minus 1 1 and 1. So this was the array, right? Let's check it once more. 1 minus 1 minus 1 1 minus 1 1 minus 1 1 1. Yeah. So from this array we can calculate the prefix sum array. We can calculate the prefix sum array given by 1 0 minus 1 0 minus 1 0 and 1. So this is the prefix sum array corresponding to this array A. We can get this prefix sum array. All right. So now let's say that I need to find the maximum length. So my question now my question is that I need to find the maximum value of r minus l plus 1 with prefix sum r is equal to prefix sum l minus 1. So this is my new question now. So this is my new question now. So how do we do this? Is that let's say that I fix my r to be here. If I fix my r to be here, then I need to find an l minus 1. Now I need to place the l minus 1 in such a location that prefix sum r is going to be equal to prefix sum l minus 1. Now prefix sum r is the value minus 1 out here. So I need to place this l minus 1 to such a place, to such a position in this array before this r, such that the value is same. So I need to place this l minus 1 to another minus 1 before this. So basically I need to place the l minus 1 over here so that I can satisfy the condition prefix sum r is equal to prefix sum l minus 1. So I have to satisfy this condition. So if I place my r at minus 1, I have to place my l minus 1 also at another minus 1 before this r. So that's one of the things. So now let's consider that instead of placing the r over here, I am placing the r at some other place. Let's say that I place this r at this r over here. So where do I place my l minus 1? Now I have two choices. I can either place it towards this on this 0, and I can place this at here. Since this value is 0 now I have two choices for this. Either I can place it over here or I can place it over here, the l minus 1. Now guys, if you look at the first condition is that we need to maximize the value of l minus r minus l plus 1. So I need to find the maximum length of subarray. So if I need to maximize the length of subarray, then we should always choose the value which is as much left as possible, Or in other words, we can say that we need to place l minus 1 to at the first occurrence of prefix sum r. So now we know that if we fix so let's recap once more. So we had a array where we had to find the subarray length with subarray sum equals 0. Now we know that subarray sum can be replaced by this prefix sum r minus prefix sum l minus 1. So we had to find the subarray sum with prefix sum r minus prefix sum l minus 1 equals 0. So we need now if we fix two index r and l, so for this index r and l, we know that the subarray length is going to be r minus l plus 1. So we now need to find the maximum value of r minus l plus 1, provided that prefix sum r is equal to prefix sum l minus 1. Now if we place my r to any of the index, so if I place my r to this 0, now I have my choice to place my l minus 1 to either of the zeros appearing before it. So which one do I need to choose? I need to choose the leftmost one as left as possible, that is the first occurrence. So if I choose the first occurrence, only then am I going to maximize this subarray length. So if I choose it here, the subarray is going to be this much. But if I choose this one, my subarray is going to be this much. So it's going to be much more bigger. So in other words, we need to place, if we fix the r, once we fix the r, we will need to place this l minus 1 at the first occurrence of prefix sum r. Is that clear, guys? If you haven't been able to follow anything, please let me know. If you have any doubts, guys, please post them on the comment section, and if you have understood, just put a thumbs up. Alright, so that being said, so now what we need to do, now that we need to do is that we need to pick up we need to place this r at or at any of the location in this prefix. For each and every location in this prefix sum array, we need to place the r, and once we place the r, we need to place this l minus 1 to the first occurrence of that value. That is, for example, let's say that let's say that I have this prefix sum array as 0 minus 1 0 minus 1 0 and 1. So this is my prefix sum array. So I start by placing my r at here. If I place my r at here, my l minus 1 is also going to be placed at here, since there are no more elements to the left. Next thing what I can do is that I can move my r to here. If I move my r to here, this is so in that case I need to place my l minus 1 in such a place which is also a 0, but there is no more 0 before this position, so l minus 1 also has to be in the same place. In another case, we can place the r over here minus 1. Same case again, we don't have any minus 1 before this position, so my l minus 1 is also going to be here. So if I place my r out here, then I can place l minus 1 to the first occurrence of 0. So since this is a 0 and we have a 0 before it, so we will place my l minus 1 to be here. So this is a valid subarray now. So this is a valid subarray. This is a valid subarray, guys. So now we can move my r to here minus 1, and we can place my l minus 1 to the first occurrence of minus 1, which is here. So now my subarray is this one. I can move my r to here, which is a 0, so I can place my l minus 1 to the first occurrence of 0, which is here. If I place it there, my subarray becomes this one. So this becomes my subarray. Finally, if I place my r out here at this one, I will place my l minus 1 at the first occurrence of this one, which is out here. Once I place that, now my valid subarray is going to be this one, and this is the answer. So the answer is 6. So now let's try and code this out. Alright, so we have been provided with some array of colors. The first step is going to be converting each element to a 1 and 0, right? So we will create another array. Let's say this array is an a, new int, and we will convert int I is equal to 0, I is equal to n, I plus plus. We will convert each element. So we will place a 1 for a red, we will place a 1 for a red, otherwise we will place a minus 1. So once we are done with this, next step is going to be creating the hash map, which maps my prefix sum to my first occurrence. sorry, over here, first occurrence, and finally we can just get out of the loop and return a max length. Okay, so guys, so what we are doing here is that first we are transforming this array. So we had the array of colors, so we are transforming this array of colors into this array of +1 and -1. So once we are done with that, now we need to create a hash map, which hash map is going to map my prefix sum to the first occurrence, to the first occurrence of the prefix sum. All right, so to calculate the first occurrences of the numbers, what we are doing is that so we are calculating the prefix sum using this variable. So we saw something similar to this in the previous example. So we are calculating the current sum. So this variable contains, basically you can say that this variable contains prefix sum of r. Alright, so this so at any point of time, current sum will contain prefix sum of r, as we have discussed in the previous class, or rather prefix sum of I, since the variable is I over here. So once we have this current sum, now we check. Okay, so now we check whether this map contains this current sum or not. If the map already contains a mapping for this current sum, that means we have already encountered this current sum before. So we don't need to bother anymore, so we put a not before it. So if this map doesn't contain this current sum, that is we are finding this current sum, that is we are finding this value for the first time, for the very first time, and that is why we map this current sum to its index. So we map this current sum out here, we map this current sum to its index. This index is the index of its first occurrence. So basically you can say, guys, that since if this map is already containing this key current sum, that means we have already encountered this. So this is not the first time it's occurring, so we don't need to bother. So that's why we put a not out here. And if it is the first time it's occurring, so we put the index of the first occurrence. We map this current sum to the index of the first occurrence. So when we are out of this loop, this map now contains the prefix sum with the first occurrence of that prefix sum. So now we reset this prefix sum variable again, and this max length is going to contain the answer. So this max length is going to contain the result of my question. So now we run the loop again, and inside this loop we are calculating the prefix sum. Once again, this variable will contain prefix sum I. At any point of time, this variable is going to contain the prefix sum of I. And when let's so this is an age case, guide. This is an age case. We will come back to this later, but before that, let's understand the code logic. So the code logic is that now once we have this prefix sum of I, we are going to find the first occurrence of this prefix sum, as we saw in the dry run. So we had a sum, so we are finding the first occurrence because we have already pre-computed this prefix sums, first occurrence of the prefix sum. So we are using this map to find the first occurrence of this prefix sum. And once we have this prefix sum, if this first occurrence is not null, that means there is a first occurrence, but this is not the first time I am finding this, then we are going to calculate the length. The length is simply the difference between the current index and the first occurrence. So once we calculate the length, we can just simply return the length. Alright, so let's try this out. Let's see if this code gives us the correct result or not. So we had the input as 7 and R, B, B, R, B, R, B. So 6. Yeah. So that is the output we were looking for, guys. So basically we have found the output now. So that's about it. So if you have been able to follow the code, just give me a thumbs up, or if you have any question, just let me know in the comment section. Will you share the codes and the notes? Yeah, Manjur, yeah, I think this PDF is downloadable. And yes, I will be sharing the code. I'll be providing a GitHub link probably in the YouTube video. I'll be giving it in the comment section probably, GitHub link where we will have all the codes. Alright guys, any other question? Okay, guys. So if you don't have any more question, let's end this session here today. Okay, that's it for that's all for today. I hope you guys have learned something new today, and see you in the next session, where we will be covering up with much more challenging questions and and we will get to learn much more complicated stuffs. So see you everyone, and bye, and have a nice time.